Hello my dear students, welcome to YouTube channel of Career Point, especially for English medium students. So how are you all? Good? As you know that we are studying this chapter projectile motion. Okay, on Thursday, Tuesday and Saturday I take these live classes on this YouTube channel. Okay, and today is the fourth lecture of this chapter projectile motion. So let's start today's session and just share this session to all of your friends so that everyone can take the benefit of this YouTube classes provided by Career Point. Okay, so before starting today's session, let me introduce you our toppers of this year NEET examination. These four students, they were regular students of our classroom course from the app, and they have secured top 50 rank, as you can see, under top 50 rank. Okay, so this app eCareerPoint, this is the app by which these students were studying from their home. Okay, so this is an amazing app. I suggest you all to download this app from Google Play. Okay, in Google Play Store you will get this app. How to install? See, on Google Play search for eCareerPoint without any space and you will see this app. Just install it. After installation, just follow your experts and you will be able to attempt the question posted by your experts. And if you want free stuff, if you want all these notes that I'm teaching here, you can get all these notes from here, free stuff. Just go to this free stuff and you will see this menu. Select medical in this section and here you will see class 11th physics NEET 2022. Okay, here you will get all the slides in PDF format. Okay, so and if you want to purchase any of our courses, see, we have both paid courses and free courses on our app. If you want to purchase any course, you can apply this code ST10 to get 10% discount. Okay, so let's start today's session. So quickly share this session to all of your friends and hit the like button. So we were studying projectile motion. What is the projectile motion? That you already know. If a particle is thrown in such a way that the angle between its initial velocity and the direction of acceleration, the angle between them is neither 0 degree nor 180 degree, then the particle will have parabolic motion, which is also known as projectile motion. So we have so many examples of this projectile motion. For example, the game Angry Bird, this bird is having a projectile motion. Okay, because its initial velocity direction and the acceleration direction, the angle between them is not 180 degree and not 0 degree. That is why it is having projectile motion. Okay, if angle is either 180 or 0, the particle has a straight line motion. Another example, most of you have watched this movie. Okay, in this movie they use this tree to throw themselves, and this is also a projectile motion. How many of you have seen this scene? They were also having projectile motion. See, they are launching themselves and their initial velocity and acceleration, they are not parallel or neither anti-parallel, and at this moment they are having horizontal velocity, maximum height they were having. Okay, and now here they land. So this was also an example of projectile motion. So till now what we have studied, that if a particle is thrown from any point, we consider that point as origin. Okay, and if the angle made by this projectile from horizontal is theta, then what we do, we just apply equation of motion in two separate direction, x direction separately and y direction separately. Now in order to apply these equation, we should know initial velocity in both of the direction. So if u is the initial velocity making an angle theta from horizontal, I can make components of u in horizontal direction, that will be ux, which is u cos theta, and in vertical direction it will be uy, which is u sine theta. Okay, because we observe this motion in x direction and y direction separately, so let us write the parameters of x direction which we have. See, we know that initial velocity in x direction is equals to u cos theta, and because acceleration of this particle is vertically downward, okay, that is why component of acceleration in x direction is 0. Okay, now if we talk about y direction, see what is initial velocity in y direction, that is u sine theta. So initial velocity in y direction is u sine theta, and what is acceleration in y direction? As you know, acceleration due to gravity has direction downward, vertically downward. So acceleration in y direction, I can say it is minus of g. Why minus of g? Because I am taking upward, vertically upward axis as positive y. So this is in downward direction. So this should be minus according to our sign convention. As I can see, some students are late, like Swati and Sivangi. But I try to be on time. Okay. So in previous class we have studied this thing. Okay, this initial velocity in x direction is u cos theta and acceleration in x direction is 0. Initial velocity in y direction is u sin theta and acceleration in y direction is minus of g. Okay, why minus? Because we have to put according to the sign convention. Okay, see, initial velocity is along positive x direction, that is why positive sign is here, and initial velocity in y direction is also along y direction, so positive sign is here. Okay, now to study this motion, what we were doing this. We were applying equations of motion in x direction and y direction separately. Okay, what is first equation of motion? It is v is equals to u plus at. Okay, so if we want to find the horizontal component of final velocity, we can use first equation of motion in x direction, because we know initial velocity in x direction, we know acceleration in x direction. Similarly, this is the first equation of motion in y direction. So if we want vertical component of final velocity at any time t, we can apply this first equation of motion. Similarly, we have second equation of motion, that is as is equals to ut plus half at square. If we want displacement in x direction at any time t, we can use this equation. If we want displacement in y direction in any time t, we can use the same equation in y direction. Okay, because equations of motion are valid here. Equation of motion are valid on that condition whenever acceleration is constant. Okay, similarly we have third equation of motion, that is v squared is equals to u squared plus 2as. Okay, and in y direction it is vy squared is equals to uy squared plus 2ay sy. Okay, so we were using these equations. Our today's topic is horizontal projection from height. Okay, so in previous classes we have derived some formula of maximum height, time of flight and range of flight. Okay, so all those formulas were valid for ground to ground projectile. If I take this example, horizontal projection from a height, that means if a particle is projected horizontally from a height, in that case it will also have parabolic motion, which is also known as horizontal motion. But because this is not ground to ground projection, so we cannot use the formula that we have derived in previous situation. Okay, our formula of time of flight, maximum height and range, they were valid for ground to ground projectile. This is not ground to ground projectile, this is a projectile from a height. So what we need to do, we need to derive some more formulas, and derivation is not complicated, because as I told you, if you know how to apply these equations of motion, you can derive formula of any situation. Even there is no need to derive the formula. If you have the question, just use these three equations in separate direction and you will get the answer. Okay. This is new student Radhe Shyam Sharma. Hello beta. So let us start this topic, horizontal projection from a height. Now, as you can see this man, he was running with some velocity, and at this time, he loses the contact from this surface. So his motion from this point to this point, okay, is parabolic motion, and it is motion under gravity. So let's start this topic. Another example for a horizontal projection from a height is this cannon. Suppose this cannon is having some height initially, okay, and the cannon throw this shell, okay, this cannon throw this shell. So definitely shell cannot have horizontal motion. Why? Because it is having acceleration in downward direction. Also, this cannon cannot have this vertically downward motion. Why? Because it is having some initial velocity in x direction. So which kind of motion this shell will have? See, this shell will have this motion which is shown by this green ball, okay. So if this is the point of projection, if I say this point of projection is O, so the cannon actual motion will be path OB. It will be not OC, it will be not OA. Is it clear? See, basically this blue path, okay, this OC is showing horizontal motion without acceleration, and this yellow path, that means OA, is showing vertical motion under gravity. And we know projectile motion is the mixture of these two. That is why I see this yellow is showing the you can say vertical displacement at any situation, and this blue is showing horizontal displacement at any situation. So its actual situation will be these, okay. You can consider these two as the coordinates, okay. When horizontal distance is this, vertical distance is this, actually the shell is here. At this moment the shell is here, okay. So this will be the motion. Now there is no need to remember all the formulas. Just if you know 3 equations of motion, you can solve the questions of this kind, okay. How? See this. Suppose at t equals to 0, this shell was thrown in horizontal direction, okay. In horizontal direction it was thrown, suppose at t equals to 0. Then suppose at time t, the particle is here, and we know for this motion, if I consider this as y-axis and this as x-axis and this to be the origin, then I can say acceleration in x direction is again 0, acceleration in y direction is minus g. So if I want to find velocity of this particle at any time t, what can I do? I can simply use 3 equations of motion. If I use first equation of motion in x direction, I will get the velocity. Its horizontal velocity Vx is same as its initial velocity in x direction. For this projection, as you can see, initial velocity in x direction is u, and initial velocity in y direction is equals to 0. See, because it is thrown horizontally, so it is only having x component, there is no y component. You can say ux is equals to u cos 0, which is u, and uy is equals to u cos or you can say u sin 0, u cos 90 or u sin 0. So what is u sin 0? U sin 0 is 0. That is why initial velocity in y direction in this case in horizontal projection is 0, and initial velocity in x direction is same as the initial speed by which it is thrown. Okay, so at any time t, its final velocity in x direction will be the initial velocity in x direction. Why? Because acceleration in x direction is 0. So what is first equation of motion in x direction? V is equals to u plus at, because a is 0, so v is equals to u. So its final velocity at any time is same. That is why for its horizontal motion, it is covering equal horizontal distance in equal interval of time. But if we consider its vertical motion, it is not covering equal vertical distance in equal interval of time due to the presence of acceleration in downward direction. Now, because acceleration is in downward direction, its speed in downward direction will continuously increase. So, if I want its velocity in y direction, that means Vy, I can apply first equation of motion in y direction. That means Vy is equals to Uy plus Ay into t. That means Vy will be equals to negative of gt. Negative sign is showing that the particle is having downward motion. Okay, downward velocity is having. So, using the three equations of motion in separate direction, we can solve each kind of question. Okay. So, what the thing that we have to remember? We have to remember these equations of motion, and we should know how to use these equations of motion in separate directions, in x and y direction separately. Okay. Now, to understand this concept, let us take an example. Before example, let us summarize this, that what we have studied. See, for horizontal projection, we have initial velocity as u, initial velocity in x direction. Okay. For horizontal, if we consider horizontal motion separately and vertical motion separately, initial velocity in x direction is u, that we know. If it is thrown by u, initial velocity in x direction is u. Okay. Similarly, initial velocity in y direction is 0. See, initial velocity in y direction is 0. Okay. Now, acceleration in x direction is 0, that we know, and acceleration in y direction is minus g because it is downward. Now, displacement along x after time t. That means we can find out this by using second equation of motion in x direction. So, x coordinate will be u into t because acceleration is 0. Similarly, if we want displacement along y direction, we can use second equation of motion in y direction. Okay. Y is equals to ut minus half gt square. Uy is equals to 0. So, y coordinate is minus half gt square. That means as time is increasing, y coordinate will rapidly increase. See, y coordinate is increasing rapidly. Okay. Its rate of increase is also increasing. But x coordinate, it is covering equal horizontal distance in equal interval of time. Okay. So, this is, if I throw a ball from here, it will have this kind of motion. If a particle is having uniform motion, it will have this kind of motion, and mixture of these two motion is the actual projectile motion if the projectile is thrown vertically from a height. Okay. So, now let's take an example. See this example. A bomber is moving with a velocity v. Okay. This plane is moving with a velocity v in the direction as shown. Okay. About h meter from the ground. The height of this plane is h from the ground. The bomber release a bomb to hit the target T. See, the target is here, but this bomber is releasing the bomb at this location. Why? Why this bomber is releasing the bomb at this location? Why not at this location? Because when a body is released, the body gains the velocity, same velocity as that of person who is releasing this. So, if I release a ball, suppose I am standing at a height h from the ground, and if I release the ball, what will happen? Initial velocity of ball will be 0, because if I am releasing any object, the object will get the same velocity as that of me. If the plane, suppose this is the plane, and the plane is moving in this direction with speed u. So, if plane is releasing something, the initial velocity of this object will be same as that of plane, because when we release something, the object that we are releasing is initially at rest with respect to ourselves, the man who is releasing. So, if plane is releasing this bomb, initially this bomb is at rest with respect to plane, that means with respect to ground. If plane is releasing this bomb will also have the same velocity as that of plane at this instant. Okay. So, if this plane release bomb here, the bomb will hit the ground here. That is why it is given in the question, that the bomber releases the bomb at this location to hit the target which is in front of it. Okay? The bomber released the bomb to hit the target T as shown in the figure. Then the relation between among theta, h and v is. That is the question. Okay, what is theta? It is the straight line between its initial position and final position. Okay, h is the height and v is the initial velocity. Now, all of you see this. If the bomb is released at this position, what will be the initial velocity of bomb? The initial velocity of bomb will be same as that of plane. So the bomb will have initial velocity is equals to v. Okay, in this question it is representing initial velocity as v, and the bomb will reach the ground like this. So basically what question is asking? Question is asking a relation between h, v and theta. If I observe this triangle, first of all, if this particle is hitting the ground at this point, that means this should be the horizontal range of the particle. How to calculate horizontal range? We will derive, don't worry. So look at this triangle. I can say tan theta, which is perpendicular by base, is equals to r by h. Okay, what is tan theta? Tan theta is r by h. I have the value of h. If I can calculate the value of r, I will get the relation among theta, h and v. Now let us calculate the range of this projectile. Listen carefully, this is important part. See, I want all of you to answer. If the particle is moving from here to here and I want to calculate the time of flight, okay, what I want to do, I want to calculate the time of flight. So which equation of motion should I use? See, from point A to point T, suppose this point is B, okay, suppose this point is B, from A to B, I want to calculate time of flight. So all of you tell me, which equation of motion should I use from A to B? From A to B, I have displacement in y direction, that is minus h, because the point of projection is considered as origin. From A to B, I have acceleration in y direction, which is equals to minus g. From A to B, I have initial velocity in y direction, that is equals to 0, because it is projected horizontally. And if I want to calculate time of flight, which equation of motion should I use? No, Prashant, we cannot use the first equation. Why? Because we do not have final velocity. In first equation, we have final velocity and time. We do not know what is the final velocity in y direction at this point, so we cannot calculate. Just think, see this parameter S, A, U and T. In which equation all these parameters are present? Second equation. Yes, very good, Prashant. So if I use second equation of motion, in y direction, I can get the time of flight. That means the time taken by this to come from A to B. What is second equation of motion in y direction? It is Sy is equals to Uyt plus half Ay into T square. When this particle goes from A to B, the time is equals to time of flight, that is capital T. So displacement in y direction is minus h is equals to, this value is 0, so it is equals to minus half g into time of flight square. So from this we got time of flight is equals to under root of 2h by g. Did you get this? So this is the time of flight, and this is the same time. This is the same formula for that situation. If I release a ball like this, it will take the same time to go downward. Why? Because if I release the ball, its initial velocity is 0, so it will take same time to go down, and this projection, its initial velocity in y direction is also 0, so it will take same time to have the same displacement. Okay, so time of flight when initial velocity is 0 In y direction, initial velocity is 0 and height is h. The time of flight is under root 2h by g. Okay. Now, because I want range, what I want? I want horizontal displacement from A to B. What is range? Range is simply horizontal displacement from A to B. So, if I want range, tell me which equation of motion should I use? I want to calculate range. That means I want to calculate the horizontal displacement from point O to B, in which time taken I know, which is under root 2g, under root 2h by g. So which equation of motion should I use? If I use second equation of motion in x direction, I will get the range. What is second equation of motion in x direction? See, from point O, from A to B, initial velocity in x direction is equals to v, that is given. Okay, initial velocity in x direction is given. Acceleration in x direction is 0. Okay, and displacement in x direction from O to B is the range that we have to calculate in order to calculate theta. And the time taken from A to B we have recently calculated, it is equals to capital T, the time of flight. Okay, now listen carefully. I am going to apply second equation of motion in x direction, that is Sx is equals to uxt plus half ax into t square. Okay, from point A to B, displacement in x direction is r, which is equals to initial velocity in x direction is v, and t is equals to time of flight. That means range is equals to v into under root of 2h by g. So I got the value of range. Now my aim is to calculate tan theta. See, what is tan theta? Tan theta is equals to r by h. R by h. What is r? R is v into under root of 2h by g and divided by h. So I got tan theta is equals to v into under root of 2 by gh. Okay, tan theta is v into under root of 2 by gh. That means theta is equals to tan inverse v into under root of 2 by gh. Okay, so this is the relation between among theta, h and v, and answer is option B. Theta is equals to tan inverse v into under root of 2 by gh. Is it clear to all of you? Okay, so this is how we are going to apply equation of motion for the questions of projectile motion. If we have ground to ground projection, okay, ground to ground projection if we are having, we can use the direct formula of range of flight, time of flight and maximum height. But if we are not having ground to ground projection, then what we have to do, we have to use equation of motion in x and y direction separately. Now which equation of motion we should use, that depends on the situation. Okay, that depends which parameters are given and which we are supposed to find out. Now see this, because as I told you, its horizontal velocity will be same. Its horizontal velocity will be same at all the points. Why? Because acceleration in x direction is 0. So horizontal velocity will not change. If the plane is moving with a constant velocity, the particle x direction velocity will be same, constant. So the plane will think that the particle is always vertically downward of it, because the velocity of plane in x direction and velocity of this particle in x direction is same always. So the plane will think the particle is vertically downward always. Okay. Now see this animation to understand this. Suppose this is the plane and this is thrown. The object is always vertically downward. See, object is always vertically downward from plane. Now as seen by the plane, as you can see, the object is always vertically downward. Okay. So this is the situation because horizontal velocity of both these particles are same. That is why they are having same displacement in same time. Okay. Prashant, if object is projected with some angle from the height, then also we will use equation of motion, and in that case initial velocity in y direction will not be 0, that will be positive. Okay, equation of motion are always valid. So is it clear to all of you? In this situation they are having same velocity, that is why it is always vertically downward. See, always vertically downward. So that this is how we hit the target. Now the next question for all of you, try to answer this. A bullet is fired in a horizontal direction from a tower while a stone is simultaneously dropped from the same point. Then choose the correct option. The bullet and the stone will reach the ground simultaneously, the stone will reach earlier, the bullet will reach earlier, or nothing can be predicted. See, in all these questions we neglect the air resistance. Solve this question. See, we have this gun. We have this gun and the time when bullet is projected, okay, at the same time a stone is dropped from the same height. Okay, so suppose that this is the ground. Suppose this is the ground. Then path of the stone will be like this, vertically downward, because its initial velocity is equals to 0. If I talk about the bullet, suppose the bullet is having some initial velocity u, okay, ux is equals to u, suppose, and initial velocity of bullet in y direction is 0. Both stone and bullet, their initial velocity in y direction is 0. Okay, path of the bullet will be like this. Okay, so it is asking to compare the time taken by both of them to reach the ground. Think what we can do. Suppose this point of projection is origin and suppose this is point A. Now see, from point O to A, if I talk about the stone, and let's suppose the initial height is equals to h. Suppose initial height is h. Good, Prashant, very good. Suppose initial height is h, then for stone, listen, for stone and for bullet, I am going to write the parameters. See, for stone, initial velocity in y direction is 0. For bullet, initial velocity in y direction is 0. From point O to A, displacement of stone is equals to minus h. Displacement of bullet is also minus h. Okay. For stone, acceleration in y direction is equals to minus g. For bullet also, acceleration in y direction is also equals to minus g. So what is the time of flight for both of them? For both of them, the time of flight is the time to cover vertical displacement equals to minus h. Okay. What is time of flight for both of them? Time of flight is that time which is required to cover vertical distance h. Okay. So because I want to calculate vertical distance, what I have to do? I have to apply second equation of motion in y direction to get time of flight. That is Sy is equals to uyt plus half ay into t square. Okay. So what is Sy, it is equals to minus h, is equals to uy is equals to 0. So it is a minus of half g into time of flight square. So for both of them, the time of flight is equals to under root of 2h by g. For both of them, the time of flight is same. Why? Because their initial velocity in y direction is same, their displacement in y direction is same, and their acceleration is same. So time of flight is same. Basically, how do we calculate time of flight? Time of flight is calculated by watching this vertical distance. Okay, this is the time taken to cover vertical distance h. So because for both of them, the time of flight is same, so answer is option A. The bullet and the stone will reach the ground simultaneously. Is it clear to all of you? So if you get any question of projectile motion, just apply equation of motion properly in x and y direction separately. Okay. Now, next question. See this question. The question says that an aeroplane was flying horizontally with a velocity of 720 km per hour. Okay, at an altitude of 490 meters. Now, when it is just vertically above the target, a bomb is dropped from it. Okay, then how far horizontally it missed the target? See the question. The question says that the aeroplane at this moment is throwing a bomb when it is just above the target. Okay, suppose this is the target. This is the target, and the plane is throwing the bomb when it is just above the target. Now think, will this bomb hit the target? Yes or no? Will this bomb hit the target? Suppose initial velocity of plane is u, then initial velocity of bomb will be u, and we know the motion of the bomb will be the projectile motion. Motion of the bomb will be the projectile motion, and the range of the projectile motion is the answer, because it is asking how far horizontally it will miss the target. So what we have to do, we have to find r. Okay, definitely this is not going to hit the target, it will miss the target, but it is asking by how much distance it is going to miss the target. So basically what we have to do, we have to calculate the range r, as we have derived recently that time of flight. What is time of flight? Time of flight is under root of 2h by g for this case. And what is height h? See, this height h is given. What is that? 490 meters. And what is u? U is 720 km per hour. If you convert it into meter per second, you will get 200 meter per second. Okay, so initial velocity is 200 meter per second, and now we can calculate the time of flight. What is the time of flight? See, time of flight, suppose it is this. Let us find out, we will calculate it later. Range of projectile. Okay, this projectile is thrown from horizontal, so its range that we have already calculated is equals to ux into time of flight. What is range? Range is ux into time of flight, and the time of flight in this case is under root of 2h by g. So what is our range? Range is equals to, put the value of ux, okay, ux is 200. And what is time of flight? It is under root of 2 into h. H is 490 divided by g, which is 9.8. Solve this, you will get range is equals to 2000 meter, and this is the answer. What is the answer? Answer is option B. Okay, 2000 meter. It will hit the target by a distance of 2000 meter. Good, Prashant. Very good. Okay. So this is how you can solve all the questions related to projectile motion by using only equations of motion. Okay. So all of you hit the like button and share this session to maximum of your friends. And if you are new, just subscribe the channel. Just hit the subscribe button and press the bell icon so that you can get the notifications of upcoming chapters and important quizzes. Okay. Now, next question for you, which is a very good question. See, what does the question says? A stunt performer is to run and dive off a tall platform and land in a net in the back of a truck. Okay, he is supposed to have projectile motion which is projected horizontally. Okay, and this person, this stunt man, needs to fall on this truck. Okay, originally the truck is directly under the platform. Okay, when this person is leaving the platform, the truck is directly under the platform. It starts forward with a constant acceleration a. Okay, acceleration of truck is a. Truck has acceleration a in horizontal direction. Okay, when the truck is just under the platform, at the same instant the performer leaves the platform. Okay, if the performer is h height above the net in the truck, then the horizontal velocity u that the performer must have as he leaves the platform is. Okay, what you have to calculate? You have to calculate this velocity v. Okay, what should be the velocity of this person so that he can fall on the net inside this truck safely? So think what we should do. Think. Basically, from his journey, from this point to this point, from this journey, if horizontal displacement of this man is same as horizontal displacement of this truck, the man will land on this truck. Okay, this concept you can use. Clear? Now let's solve this question. See, suppose this is the point of projection O and this is the point where he is going to land. Okay, so if I want to calculate time taken by man to reach truck, time taken by this man to reach the truck, to land on the truck. Okay, we should write to land on the truck. Is equals to under root of 2h by g, that we have already derived. Okay, now what is the horizontal displacement of this man in this time? See, horizontal displacement of man in time t. What is the horizontal displacement in time t? That is basically range. What is this? This is range. Range is equals to its initial velocity u in time t. Why? Because acceleration in x direction is 0 and acceleration in y direction is minus g. Okay, so the distance covered by this man in time t will be simply speed into time. Now, horizontal displacement of truck in time t is s. And what will be s? S will equals to ut plus half at square, because initial velocity of truck is equals to 0 because it is starting from rest. So its displacement in horizontal direction in time t is equals to half into its acceleration, which is a, into time square. Okay, so this is the time taken by this man to reach the truck, and horizontal displacement of this man in time t is u into t, and horizontal displacement of truck in time t is half into a into t square. Now listen carefully. If this man wants to reach this truck, then if man lands on truck, in that case the horizontal displacement of truck should be equals to the horizontal displacement of man. Okay, when truck is here and man reach at this point, he will not be able to land on the truck. If truck is here and man reach at this point, he will fall on the ground. So if man lands on the truck, that means horizontal displacement of truck in time t should be same as the range distance traveled by the man. Okay, so what is this s? It is half a into t square. What is range? It is u into t. If they are equal, then t will cancel out t and you will get u is equals to half into a into t. And what is t? It is under root of 2h by g. Under root of 2h by g. That means u is equals to a into under root of h by 2g. Okay, and what is the answer? Answer is option B, a into under root of h by 2g. Is it clear to all of you? So this is how we can solve any problem of projectile motion which is not ground to ground projectile, okay, only by using three equations of motion separately in y direction and x direction. Okay, so that is enough for today. See, if you have not this app, I suggest you to download this app because this is very, very, very important. This is very beneficial app to study from home. Okay, you can take classes from this app also. Okay, how to download this app? Just go to Google Play, search eCareerPoint app and download it. Once you download, follow your experts and you can get all these slides which I am teaching on YouTube in this free stuff. Go to free stuff and you will see this window. Select medical and move to this section. 11th Physics NEET 2022 English Medium. Here you can get all the previous lecture videos and along with that the notes with annotation. Okay, so those who are new, subscribe the channel and share to your maximum friends. Okay, and hit the like button those who are watching this, and if you want to ask anything, if you have any query, just let me know in the comment section. Okay, so that is enough for today. This is Sumit Talwani signing out. Thank you very much. See you in next lecture.